Okay, Assalamualaikum. Now, part 4 of the discussion of chapter 5. So, we are using a method called Runge-Kutta of order 4 method, RK4, for solving the initial value problem. This method is quite similar to Runge-Kutta of order 2. Instead of 2 terms in Runge-Kutta 2, we have 4 terms now. That's why we call it 4, order 4. So here's the formula. So this is a formula. yi plus 1 is yi plus 1 over 6 of k1 plus 2, k2 plus 2, k3 plus k4. So we have k1, k2, k3, k4. So the extra terms here are k3 and k4 that we need to find. What are these terms actually? k1 until k4. k1 is this function hfxy, capital X, capital Y, where x and y's are values, the values are given here. K2, so the formulas are the same, K1, K2, K3, K4, only x and y values differ from each other. Okay, one from another. So for the first one, x is just small xi, y is just small yi. So for K2, something different, which is this one here, and y also. And for K3, so x, the same as the one before that, but y is different. We have K1, this one is K2. And same thing with K4, which is this one here. So you don't have to worry because in the exam, all these values of K will be given. And also the formula will be given. Okay, we discussed the same example as what we had earlier in Taylor as well as Runge-Kutta of order 2. We have this problem. Okay, and x is between 0 to 0.8. We don't have r this time. R refers to the previous method. Okay, we have initial value, which is when this one here, same one, when x0 is 0, y0 is minus 1. Okay, the interval v is given as 0.4. We need to find this one here and this one here. So the first one is y1, the second one is y2. Okay, we need to find. Better illustrated using this diagram. The same diagram as we use in Taylor as well as Runge-Kutta of order 2. So x0, y0 are given. We need to find y1, y2. So the very first thing that we need to do whenever we solve this problem is to draw this diagram. Make sure you do that. Okay, so the equation is this one here. So make y prime as a subject. We have this. So this is function of x and y, small x, small y. Now we change to capital X, capital Y. Same thing, except just small x becomes capital X, small y becomes capital Y. This is what we get. So this is our f. Okay, same thing as in Runge-Kutta over the 2 method. Okay, now we are ready for the iteration. We start with I equals 0. x0, y0 are the given values from here. So these are the initial values. And now we are ready to compute k1. K1, in order to compute k1, which is this one here, we need to find capital X, capital Y, which are given here. So I is 0. So we have x0, y0, 0 and so we have x and y, 0 and 1. So with that, we can find k1. So k1 comes from here, So just apply I equals 0 into x and y. So we get 0. And then k2. Okay, we refer to this one here. Capital X, capital Y. So just put in the values, we get capital X, capital Y. And then we can find k2 using the same formula. So we get this. Let's continue with k3 using this formula, this one here, capital X, capital Y. Okay, so put in the values. So we get 0.2 for capital X. Capital Y, we get minus 0.888. So with that, we can find K3, using this equation. So we get 2, 2, 6. And same thing with K4. So this is the formulas for K4, capital X, capital Y. So we put in the values, we get 0.4 and minus 0.774. So with that, we can find K4, which is this one here. So we have K1, K2, K3, K4. So we're now ready to plug in the values into this general equation and put that in. We get the first solution, which is minus 0.778. Okay, finish with the first iteration, which gives the value of y1. This is y1. So the second value is y2. We need to continue the iteration with I equal 1. So the given x will be x1 and y1. x1 and y1 are the values that we had. So x1 is the next value, which is 0.4. y1 is the value that we obtained earlier. So with that, just repeat this whole thing. Just repeat the same step as in I equal 0, but this time I equal 1. So we compute K1, this one here. So this time I equal 1. So we have x, y, and then K1 put into this equation. So we get 430. Repeat with K2. So this time x and y, x, y with I equal 1. So we get 0.6 minus 0.563. So with that we can find K2, which is using this equation. So we get 639. And continue with K3. Same thing with K3, using this set equation for capital X, capital Y with I equal 1. So we get 0.6 and 459. So with that we get K3, which is from this equation. And we get 654. And finally K4, we use the capital X, this one here, capital Y, which is this one here. Put in the values. So we get 0.8 minus 0.124. And finally we get K4, which is 928. And finally, we put in the solution using this equation, the general solution, and put in values of K1, K2, K3, K4. We get minus 0.121. So the answers are a little bit different from RK2 and Taylor. The difference is because of the number of decimal points, which is 3. We should use a higher value, for example, 6 and 7. Then we can see the difference is not so much after that. Okay, so that ends part 4 of the discussion. So that ends the discussion on initial value problem. So we will continue with boundary value problem in part 5. Okay, thank you.